So last time, guys, we started we started a series, a short series of NE555 and understanding the different modes in which you can connect the NE555 and what really happens inside the NE555 to give you the output that you need. So we started off with the Bistable, which is a free running oscillator, and we understood what really happens inside for it to give a square wave at the output. So for the Bistable means that it doesn't have a stable state. That's why it turns on and off without external triggering. Next video we did this monostable mode, and we understood, and I tried to explain what happens. As you remember, we said that monostable just means that it has only one stable state. And once I pressed this switch, the output turned on for a specified period of time, which is determined by the circuit constants, which we said are this capacitance value and the resistance value right here. So you take them, you calculate them using the formula. If you can remember the period, the time we said is equals to 1.1 RC, like that. So 1.1, which is the constant of the formula, R is the resistance, then the C is the capacitance, and then you get your time in which the circuit will be on once you turn the switch on, once you push the push button. So today we want to do a bistable, which is the last mode in which you can connect the NE555. And for a bistable, the name just suggests that it has two stable states, and you can see it has two switches. This is the external circuitry. If I put my hand here, this is the external circuitry that you need to connect your NE555 to give you a bistable output. So we have two push buttons, two resistors right there, which are normally just the same value for the resistors, then the two push buttons, and then you're done. So for a bistable, once I press this, the output will be on, and nothing happens even if I press the switch again. It is only turned off by the other switch. So this first switch is for turning it on, and the other switch is for turning it off. So that's basically what a bistable does. So let's try to understand the operations inside. So initially, once you turn on your circuit, VCC right there, once you turn it on, pin number 2 and pin number 4 are set high because they are connected to the VCC via the resistors R1 and R2. So they are set high. So since the trigger pin number 2 is set high, as you can see here, once the inverting input of the comparator is set higher than 1/3 of VCC, remember this is 1/3 of VCC, and this is 2/3 of VCC. This point is 2/3 of VCC, then this point is 1/3 VCC, since this is a voltage regulator containing 5 kilo ohm resistors right there. So as we were saying, once you turn on the circuit, the pin number 2 and pin number 4 are set high. So pin number 2 is set high, and it's higher than 1/3 of VCC. Since the inverting is higher than the non-inverting, it means that the output will be 0. Okay, the output will be 0. So since the output is 0, it will enter the Q bar, and Q bar output will be 1. That 1 enters the inverter here at the output, the output inverter. Once it has entered the output inverter, it's going to be 0. So initially the circuit starts when it is 0. So it is 0. Okay, so in the next phase, once I push this push button. Okay, another thing is you have to note, pin number 6, which is the threshold, is not connected, meaning that at all times this comparator will be giving a 0 output. Okay, so at all times this is going to be giving a 0 output since we have not connected our threshold pin. So let's go to the next step. So in the next step, once you push this push button switch, once you push it, then current will come and will choose the shortest path possible. So it won't go to the trigger pin, it's going to go to ground straight because that's the shortest path for it. Once it goes to ground, meaning that pin number 2 will be low. The low, okay, since the pin number 2 is low, 0, and it's lower than a third of VCC, it means that this comparator will be giving a one output. That 1 is going to enter the S input of the flip-flop, and the output Q bar will be 0. That 0 is going to come into this inverter. It's inverted to become 1. So once I press this switch, the output turns on. Okay. And once I release it, nothing is going to happen. Even if I push it once more time, nothing is going to happen. Why? Remember we said that the threshold pin is 0 at all times because we have not connected it. And since this comparator is giving a 0, the output is not going to change. It's not going to change because this has to be 1 in order for it to change in what you give at the input right here. So if you give 1 right here, then the output is the only time when the output will be changing the input which you have here. So even if you push and release, if you release, automatically this trigger will be high because it's connected to VCC. Once it's high, it's going to be 0. Once it is 0, what we expect is the output to be 0 if it aligns itself with this pin. If this is 1, then it's going to reset the output to what you have at the input S right here. But since this at all times this point is 0, then this output is not going to be manipulated by this comparator at all. It's going to be in one state only. So the only way to change the values, or the only way to change what you have at your flip-flop, is to press this reset pin, and that's why we have connected it to this other switch. So the output will be remaining on even if you press this switch. It won't change the value of the output. The only way to change the value is by clearing all data that is recorded by this flip-flop. So the only way to do that is by pressing this reset pin. If you can see, the reset pin is set high also. It's also set high, but it has an inverting point here. So meaning that because it's high, it's going to be turned to 0. So the only way to turn it on is by pressing this, then it's going to be on. So once you press this, then current will be choosing the path, or the shortest path is be going to ground. Once it goes to ground, this will be getting a 0 input. That 0 is going to come. That 0 comes inverted, becomes 1. That 1 clears everything that you had in your flip-flop and returns it back to its initial state, 0 0. That's what gives the circuit. That's what changes the output here to be 0. Yes. So that's basically how the bistable mode operates. So I have the circuit right here, and we are going to see that operation actually in practical. So let me just connect it and let's see what really happens. So it's on. So as we have said, we have two switches. We have the on switch and the off switch. So the on switch will only be turning the LED on at all times. Only on. It cannot turn the LED off. So once I press it, the LED is on, and nothing is going to happen. Even if I press it one more time, nothing is going to happen because the flip-flop, or the R input of the flip-flop, is always 0 because the threshold pin, we have not connected it. So it's always be giving a 0, meaning that this output cannot be manipulated by these inputs at all until this becomes 1. And since this cannot become 1, so the only way is to press the reset pin right here. So the reset pin is this one. We have this push button, and once I press it, it's going to be turned off like that, and nothing happens. Even if I press it one more time, it cannot turn the LED on. The only way to turn it on again is by pressing the trigger pin right there. Once you press it, nothing happens. Even if you press it 1,000 or 1,000,000 times, nothing is going to happen until you press the reset pin. And then when you press the reset, it's going to be turned off, and this reset cannot turn the LED back on. So that's basically the circuit. That's basically how you can connect a bistable mode. This is very useful circuit. You can use it in your projects if you want a specific a push button or a specific switch to turn something on and another one to turn it off specifically. So you can use such kind of circuit to do that operation. So I really hope you have understood, and yes, so all of those three modes which we have been doing are all the modes that which you can connect your NE555, either a stable, monostable, and bistable. So you can do those projects at home. Try to understand the NE555, try to do a lot of more projects or a lot of more practice at home, making this and understanding them widely. So I really hope this video helped, and if it helped, please subscribe, and hope to see you next time. Goodbye.